Welcome to Spaceverse, your portal to cosmic adventures. Buckle up, because what we thought we knew about the universe might be completely wrong. Scientists are now questioning whether the universe even has a set age, and they're rethinking dark energy's role in its rapid expansion. Instead, they suspect something even more mysterious is at work. The James Webb Space Telescope has been delivering jaw-dropping discoveries, revealing cosmic structures that no one expected. These mind-blowing images have left astronomers speechless, forcing them to rethink the very foundations of our understanding of the cosmos. Just a few months ago, some of the world's top cosmologists gathered at the Royal Society in London to ask a bold question: what if our entire model of the universe is outdated? The reason? Recent high-precision observations have shaken the long-standing theories we've relied on for decades. Professor Sabir Sarkar, a cosmologist from the University of Oxford, put it bluntly: in cosmology, we're still using a model first proposed in 1922. While our data has vastly improved, the theoretical framework is way past its expiration date. More and more leading astronomers are starting to agree. Could we be on the brink of a revolution in how we see the universe? Stay tuned, because the answers might be wilder than we ever imagined. For centuries, people believed the universe was unchanging, a constant in the vastness of space. But in the 20th century, scientists made a groundbreaking discovery: the universe is actually expanding, with galaxies moving away from each other. The big question that followed was whether this expansion would eventually slow down due to gravity pulling everything back together. Scientists looked to distant exploding stars, which gave them a more accurate way to measure the universe's expansion. They expected to see it slowing down over time, much like a ball thrown upward gradually slows as gravity pulls it back. But then something unexpected happened. Instead of slowing down, the expansion was speeding up. This surprising revelation completely flipped our understanding of the universe on its head. To explain this, scientists introduced the concept of dark energy, a mysterious force that's actually pushing galaxies apart, counteracting the pull of gravity. Dark energy makes up about 70% of the universe and is one of the biggest unanswered questions in modern science. All of this, along with ordinary matter, forms the lambda-cold dark matter model, the current leading theory of how the universe works. By applying this expanding universe model, scientists calculated the age of the universe by essentially rewinding the cosmic clock, determining that the universe is about 13.8 billion years old. Here's the catch: the current model of the universe uses a simplified equation that assumes everything in the cosmos is smooth and expanding at the same rate everywhere. But new images from the James Webb Space Telescope are showing us something mind-blowing: massive galactic filaments separated by enormous voids, empty spaces beyond our wildest imagination. To make things even more puzzling, astronomers studying 1.5 million quasars have discovered something odd. There are about 0.5% more quasars on one side of the sky than the other. This hints that the distribution of matter in the universe isn't uniform at all. There are these giant galactic filaments and vast cosmic voids scattered throughout space. But here's the kicker: our standard cosmological models don't account for such colossal voids and structures. And with the Webb telescope uncovering even more of these anomalies, it's becoming harder to support the old model of the universe. So, how do we explain this new cosmic mystery? Enter timescape cosmology, a fresh theory that suggests the huge voids and cosmic structures might be affecting time itself. The idea is that time flows differently depending on the density of matter around it. Imagine this: an atomic clock inside a galaxy might tick a third slower than one placed in the middle of a vast, empty void. Now, consider this over the course of 13.8 billion years. Time would have passed faster in these cosmic voids compared to matter-rich regions. So, the universe doesn't have one single age after all. The age of the universe could actually vary depending on where you are. In the empty voids, it might be billions of years older than in the dense regions filled with galaxies and stars. And here's where it gets even more mind-blowing. Since more time has passed in the cosmic voids, these areas have experienced a greater stretch of space. Basically, the universe has expanded more in these less dense regions. So, if you were to look at an object on the far side of a void, it would seem to be moving away from you much faster than an object on the near side of the void. This happens because the space within the void has stretched out more over time. Now, imagine this effect happening throughout the entire universe. As time passes, the voids are expanding even faster, becoming an increasingly larger part of the cosmos. This creates the illusion that the whole universe is expanding more quickly. But in this theory, there's no need to introduce dark energy. The faster expansion in the voids naturally explains what we're observing. In 2017, astronomers from the University of Canterbury in New Zealand tested this timescape cosmology theory against real observations and found that it actually fit the data a bit better than the traditional lambda-CDM model when it comes to explaining cosmic expansion. Here's the really fascinating part. Scientists now think our very own Milky Way galaxy might be located within one of these vast cosmic voids. Picture this. You're floating in an endless, empty ocean, and the nearest sign of life is billions of light years away. Sounds like something out of a sci-fi novel, right? But it could be our reality. For years, astronomers have speculated that the Milky Way might sit near the center of a massive cosmic void, though they weren't sure until recently. New images from the James Webb Space Telescope seem to confirm that we might indeed be right inside one of these enormous voids. Recent studies are raising an intriguing possibility. What if our Milky Way galaxy is located at the center of a supervoid, an immense, empty region in space stretching about 2 billion light-years across? Scientists believe this supervoid could help solve one of the greatest mysteries in cosmology, the Hubble tension. The Hubble tension refers to a strange dilemma where different methods of measuring the universe's expansion give conflicting results. To tackle this mystery, a new study led by scientists Sergei Mazurenko, Indranil Banik, Pavel Krupa, and Moritz Hosselbauer examines a giant region called the Keenan-Barger-Cowie, or KBC supervoid. This vast space has far fewer galaxies than usual and spans up to 300 million parsecs. This cosmic void poses a unique challenge to the standard model of the universe. Observations of the KBC supervoid don't quite align with what the current model predicts. The researchers focused on two key issues: the Hubble tension and something known as bulk flow, the movement of galaxies through space. According to the standard model, galaxies should be moving at certain speeds. But new data shows that galaxies, especially those near the KBC supervoid, are moving much faster than expected. These surprising speeds don't match the predictions of the current model. To tackle this, the team used a fresh approach. They applied a mathematical model developed by Moritz Hosselbauer to predict how galaxies should move. If this new model is accurate, their findings suggest that the discrepancies in galaxy speeds could be explained. In simple terms, their new model helps align the observations with what we'd expect to see. And it points to the possibility that the Milky Way might be situated at the center of a supervoid, much like the KBC supervoid. Researchers suggest that if our Milky Way galaxy resides inside a supervoid, you'd notice that things around you are being pulled toward the denser regions of the universe. In other words, if you're sitting in the center of this void, space around you expands faster than the rest of the universe. From this perspective, observers would measure a higher rate of expansion compared to what we see in the distant early universe, much like the expansion we observe today. What we've learned so far is that the timescape model offers fresh insights into how enormous cosmic structures and vast voids could help explain some of the universe's biggest mysteries, all without needing the idea of dark energy. And that's all for today in Spaceverse. Hope you found this as fascinating as I did. Before you leave, drop your thoughts about this discovery in the comments. Thanks for tuning in.